gentlemen, hello and welcome back once again. It is Tuesday at 4 o'clock Eastern, which means it must be time for the briefing room. Yes, indeed. My name is Eric Cavanaugh. I will be your host for today's topic, and it's a good one, folks. The exact show title is Data Wrangling and the Art of Big Data Discovery. So let's dive right in. Here's a slide about yours truly, and enough about me. As many of you now know, the mission of the briefing room is to reveal the essential characteristics of enterprise software. We do that by hosting live analyst briefings. We get an analyst who takes a briefing from an innovative vendor doing something interesting in our space that we cover, and we find out what's going on. The whole show was really born of an idea when I watched my partner, Bloor, take a briefing from a vendor many years ago, and I was so impressed at how quickly he was able to bring out a very useful conversation, and that's because he knows which questions to ask. He understands the marketplace, he understands the dynamics, he's been studying database for almost 30 years, something like that, so quite a long time. And we have all kinds of analysts who join us. Of course, we're always happy to have our very own Dr. Bloor on the line, as we do today. So we do different topics each month, and that's really a service to our audience. We're trying to give you, as best we can, apples-to-apples comparisons during these programs because, let's face it, if you're about to purchase some enterprise software, it's usually not cheap, which means you're going to want to really make sure that you're getting the right product that does what you need it to do. And frankly, if you just rely upon brochures or websites or reviews that are written by other folks out there in the market, well, that cannot be the most best, I should say, way to get your information, because you want to make sure that you understand the nitty-gritty and really figure out what's going on with a particular product, how it was designed, so on and so forth. So the topic for today, we've been thinking about how to demonstrate the difference between dealing with traditional data, which relational databases are usually used for, and big data, and there are some very significant differences. You've heard, of course, the 3 V's, volume, velocity, and variety. That's part of the problem, but really it has a lot more to do with the nature of the data itself. Yes, the volume is significant, but the nature of the data, depending on where it comes from, whether it's machine-generated data or social media data, sensor data, for example, machine logs, computer logs for various kinds of applications that are running in the cloud, for example. A lot of this stuff is cloud infrastructure focused, obviously. That data needs to be managed, and it needs to be managed in different ways depending upon where the data comes from. Now, the good news that I like to talk about is that machine-generated data is usually going to be pretty darn accurate in terms of representing what it is, because machines don't lie. Machines are going to tell you what's happening with them. Sometimes they are set up poorly. Sometimes a certain part of a machine might break, for example, and then you have to kind of decipher what those codes are telling you or understand what they're doing. But once you have a good mapping of all the different kinds of data that are coming in, well, that's when you can start playing around and doing some useful stuff with it. And I think our presenters would refer to that as wrangling. So wrangling is a kind of data preparation that's focused on big data. So I threw out our channel locks here and simply threw some points up. Hammers aren't good for plumbing. Plumbing is one thing I will never try to do by myself. I can tell you that right now. I'll call the plumber every time. Because if you make a mistake, it's going to get really, really wet. So there is a good metaphor there or analogy to working with big data. And the fact is that big data does require this new set of tools. That doesn't mean you should throw away your old toolbox, because certainly when you want to integrate the insights that you get from this big data into your operational systems, well, that's when you need to go back to your old ways and old methods for integrating data and integrating streams of interesting tidbits. So with that, I'm going to introduce, of course, Bloor. He's going to be on the show today, taking questions from our friends at Trifacta and Zoomdata. So here's the slide about our 2 vendors. They're coming together to do a presentation. Trifacta, you can see, offers a platform for data transformation and preparation. Very interesting company. In fact, the guy who's going to be speaking first has a very long history in this business and knows some of the big names who really helped start the whole relational database industry. And of course, we have Zoomdata as a big data exploration, visualization, and analytics platform. So this is a great combination here. You've got to prep the data, then you have to explore the data. These are 2 very, very different things, and that's why we have 2 companies focused on them. So you see Dr. Joe Hellerstein is Trifacta's Chief Strategy Officer. He knows Dr. Stonebreaker. He studied with him many years ago out at Berkeley. Many of you may know Dr. Michael Stonebreaker as arguably the grandfather of the relational database. He has started various companies over the years, a number of them. Vertica, for example, is one of his, and VoltDB is another one of his. So he's been around for many, many years, Dr. Stonebreaker. And then we'll hear from Russ Cosentino, Vice President of Marketing and Business Development at Zoomdata. So with that, actually, let me go hand it over to Joe. He's going to share his screen. And Joe, take it away.
Terrific, thanks. All right, so we did get a little briefing here on our speakers. So I'm Joe Hellerstein, and I have two roles in life. I'm a professor here at Berkeley in the Computer Science Division, where I've been since the mid-90s, and I'm the co-founder and chief strategy officer at Trifacta. Russ is the VP of Marketing and Business Development at Zoomdata, and we'll hand the microphone over to him shortly. So Trifacta, a little history. The company was founded in 2012 based on a joint research project I led with folks at Stanford that was bridging the database research community, which represented by me, and the human-computer interaction data visualization community represented by my co-founder, Jeffrey Hare, who's one of the leading lights in data visualization. We had a project called Data to the People, and we would meet in San Francisco every week or so. The mission of the project at the time was to facilitate interactions between people and data throughout the analytic life cycle. We had a portfolio of research projects. The one that we chose to start the company on was one that I co-led with Jeff at Stanford, actually, called Data Wrangler. That's an open source web-based application that's been used by tens of thousands of people. You're welcome to play with that. And really the mission of Data Wrangler was to help with these problems of dealing with data that may be messy or unprepared and getting it ready for analysis. The mission of the company, Trifacta, really is to look for these messy problems in data preparation, in data analysis, and come up with elegant solutions that get people past the pain. Sometimes it's like called the 80% problem of data analysis is preparing the data. We have a wide variety of customers. You'll see across a bunch of industries, some of the logos here. This is a very horizontal problem. So in addition to the companies represented here, we have companies in consumer packaged goods, pharmaceuticals, consumer electronics, and of course you see a variety of things here. Lockheed Martin actually representing healthcare in this case.
Yes. I think you need to share your screen still, Joe.
Oh, I haven't shared my screen.
No, sorry.
My apologies. Let me figure out how to do that. So I'm just talking to a wall here.
All right, very top left-hand corner of your screen, go to Quick Start.
All right, Quick Start. Yes, indeed. My regrets. Good.
No worries.
Okay, thanks for calling that out. So where were we? This was the slide we were on. So customers including LinkedIn, Autodesk, Orange, Lockheed Martin in their civil side, on the healthcare side, market share, and then, as I mentioned, a variety of other verticals represented as customers. So very horizontal problem. You know, I'm sure you've all seen PowerPointware that looks kind of like this, traditional approach to data management from back in the days when I was a student. You had, you know, your data sources, your ETL or perhaps ELT, loading a data warehouse and data marts. You had the marts and databases that you actually got to do the work on for accessing the data, running SQL, maybe doing some fancy things with that SQL even to do analysis, and in some case driving these things, and I saw this firsthand when I worked with the folks at Greenplum back in the mid-2000s, driving these traditional platforms to even some reasonably sophisticated data products and solutions. But this was, you know, the old world. And one of the frustrations of working in that world was the number of people involved in the process. So to put together a software architecture like that, you had a bunch of stakeholders who had very real jobs managing these systems and governing the way they were used. But if you're the business analyst on the right-hand side of this picture and you're trying to get your job done, you're trying to be data-driven and make data-driven decisions and build data-driven products, there's a real thicket of people and systems to work through to even get started working with a new data set. It doesn't have to be that way, and we have lots of proof points, and Russ, I'm sure, can speak to them as well, in the environment today where even with very large volumes of data, you can break this down into some folks to set things up in IT and some folks on the business side who are really intimate with the data, and most of the work ends up happening on a case-by-case basis in the hands of the business analyst in a self-service fashion. So when you think about how big data is deployed in some of these environments, data gets dropped into an environment like the Hadoop file system without need for schema in advance, without need for a committee to come up with the normalized entity relationship model for things, without necessarily even need for governance of the resources, which might be shared. Things can just kind of get plopped down, and you figure it out as you go. And this is terrific for onboarding new data sets, for driving a culture where data is a resource that everyone can take advantage of. But it does put some burden on the folks at the end of the pipe, on that business analyst, to be able to be self-service, to be able to do their own data preparation and their own exploration and visualization. And this is where companies like Trifacta and Zoomdata come in with very different approaches to how to empower these people to do tasks that were traditionally prepped and managed by IT folks who, while they were experts in data, weren't necessarily experts in the data being studied and the domain of use. So this is the pipeline we're going to sort of illustrate today. And with this, I'll hand it over to Russ to talk a little bit about some of the business benefits in this context.
Yeah, thanks, Joe. And just building on to the theme of data to the people, it was interesting because the Aberdeen group did a research paper recently, and they highlighted some areas in which real-time data, the velocity of data can have an impact on business. And obviously, if you think about it, when we can deliver information from the source through the data wrangling and through the visualization to the business user, we can have an impact on the cash because we're going to be able to make decisions faster and we're going to see changes in the business. And obviously, that leads to pipeline growth, and if we're managing our assets more effectively, then the real time is going to have an impact on our cost reduction. When we look at big data, which is the next slide, we think about how we are looking at data across the organization. Obviously, big data is having an impact on corporate America. More and more data is being stored in modern databases, and we need new technologies to take advantage of it. And what we find is that when businesses go ahead and find a way to capture 100% of the data, then the decision quality is obviously going to be going up because they're no longer looking at the sample of the data. They're going to be able to address all the anomalies within the data and essentially make better decisions. And the last part is interactivity. So it's great to have big data, it's great to have data that's real time, but it also has to be designed for the business user. And this is basically data to the people in that form. Because the tools and the systems that are out there today cannot require huge amounts of training, they cannot be difficult to use. They really have to be made for the business user. They have to be interactive so that people can respond to information as it becomes available. And what that does is it ultimately increases collaboration because ease of use makes it easier for people to share conclusions and make faster decisions. And ultimately what we're trying to do is drive up user adoption so that people are participating in the decisions across all the different categories of business. So pass it back to Joe.
Okay, so what we're going to do now is I'll take you with Russ's help through a pipeline here of a scenario, and I'm going to translate over here to my web browser where actually before I do that, I'm going to show you some data. So the scenario we're going to look at here is I'm going to play the role of a data analyst at a telecommunications company, and what I'm interested in studying here is I'd like to take data from the data warehouse, which has been dumped out, it should be in clean form, on my customers, and I want to take some log data, it's called detail record data from cell towers, and I'm working with the marketing team to understand regional differences in the behavior of callers and what their call patterns are to discern what kinds of promotions would be most beneficial in different areas of the country. So we're going to do some relatively micro-targeting here with the marketing team. So we got these two data sets, and they've just sort of been landed on my desk, these data sets. Now, I, as a data analyst, am familiar with this kind of data, much more so than the IT department. I know what the various attributes should be, and I can go dig them out. But I'm not necessarily familiar with these two data files that have landed on my desk. So just to give you an example, what we're looking at here is a call detail record dump in a text editor. And there's some structure in here, but this is not data that's ready for analysis. And if we tried to load this in a visualization tool, we'd be pretty stuck. Moreover, it doesn't have the customer data that I want. So I'm going to quickly step you through how Trifacta allows people in just a few minutes to put together these multiple data sources, clean them up, and prepare the data in a way that tools like Zoomdata can be used then to do exploration. So let's switch over here to the Trifacta interface, and let's look first at that nice customer data, because I knew that was coming in a CSV, and I should be able to look at it. It's a fairly clean table from the warehouse. And, you know, you just look at this, and I can see as the telco guy, this is my data. I get it. Over here, I have my IMSI. That's my International Mobile Subscriber ID. That's my key for customers, and I'm going to be using that, I'm sure, in my call detail record data. And I've got some typical data you'd see on contracts and customer names and social security numbers and where they're from. The thing I want to emphasize is that while this all looks very familiar, this was a raw text file. So everything we're seeing on the screen that's being added is being done by analyzing a sample of that text file and presenting this up automatically in this Trifacta interface. And you can see we're getting things like data type. So it's inferring that this column is of type state. And then it's also showing me a distribution of these states, you know, from most frequent to least frequent, right? When I look over here at zip codes, those are numeric, so it's showing me a distribution from smallest to highest value, which is a different visualization. And as it's getting these data types out, phone numbers, emails, and so on, it can also tell me a little bit about data quality, because it can do validation that the data is what we think it might be. This is mostly numbers. It's not entirely numbers, though, so we may want to dig in and see what's going on in here. All this is coming somewhat automatically, and in fact, you know, this file was put in this format by Trifacta, auto-generating some steps in a script here to wrangle the data. So it split it into rows and columns and pulled a header out into the metadata, and all that happened. While we can see it visually, it all happened under the covers automatically when we opened the file. Now, in version 2 of Trifacta, we added visual data profiling. That's going to allow us to dig rather deeper into this data and have a better look at it. So why don't we go ahead and look at some of the details of these columns. And with each of these columns now, we're going to get an in-depth data profile of that column. So we might want to look, for example, at last names. And we'll get a distribution. Here's the top values you can scroll through. You get some data quality summaries. These all validate as strings. There's 100% unique values, which is interesting. So this could be useful as a key, although probably we know from our domain it's not. And then because it's a string data type, it's giving us distributional information on string length. There's no crazy strings in this field, so that looks pretty good. As we look at more interesting types, you know, you might look at states. Again, they're strings, okay, and so we'll get a distribution on the values and string lengths. They're all linked to, which is a good sign, so this column looks pretty clean. But as we scroll down, Trifacta is aware that this is a geotype, and so it's able to provide a geographic view of the data with density plots on the states. Everything that we see on screen in Trifacta, from the grid of data that we started with, that familiar grid here, everything here is interactive. You can interact with the bar chart visualizations, you can interact with the data values, and then when we go back to the column details, you can interact with things like maps. And as you interact with these things, you're seeing that suggestions for how you might want to clean up your data are being proposed to you up here in the transform editor. And this is uniform throughout the interface. So as you point at data, Trifacta is a step ahead of you saying, gee, I see you're interested in Wisconsin. Is it that you want to keep only rows from Wisconsin, or delete the Wisconsin data, or perhaps reset the Wisconsin data to something else? So everything we're going to see and touch in the Trifacta interface is driven around helping people transform data. Now, this data is actually pretty clean. One thing we might want to do is sort the columns by missing values and look at something that has some missing values and try to clean them up. So the occupation data is missing some values, okay? It's 569 of these values are missing. And again, even the quality bars are interactive, so I can click on that missing values component of this quality bar and get some suggestions. We could delete or keep the rows with missing values. What I actually want to do is I want to replace those missing values, maybe with a token that will represent that they're missing, like NA. And instantaneously, when I do this, even though I haven't even applied this transform yet, I'm just previewing what it would do. We see what it would look like in the distribution. So here's that NA bar. It's actually now the most popular value. And we can see in the grid as well, if we go back to the grid and we go over to the occupation fields, we can see the rows that it's changed. And all of this stuff is done interactively. If we accept this transformation and add it to the script, then it just becomes part of the data. All right, so that's the typical transformation you might do on a very simple file. Let's look at this messy called detail records data and quickly clean it up. So I look at this, and I'm a telco guy, and I can see my friend, the International Mobile Subscriber ID over here, but it's been embedded in some kind of crazy composite field. Now, you might need to write a program traditionally to pull this out, But in Trifacta, this is all interactive. So I'm just going to say, look, I'm interested in that, and I'll start to get suggestions and previews of what to do with this data to pull it out. So this one didn't look quite right. Let me give it another example. This is a International Mobile Subscriber ID. And with these two examples, Trifacta gets the picture, and it says, oh, I see, you're trying to pull a column out that looks like this. And that's indeed what I want to do. If I want to go look at the text, it's pulling things out after a left angle bracket and before a slash, which is exactly what I wanted here. So I'll add that to my script. I got my IMSIs. That's great. I can even drop this column. I don't need it anymore. Next thing I might want to do is break apart this column by slashes so I can get these call types and disconnect reasons pulled out. Because I want to study why are people disconnecting from the service or why are calls being disconnected. So that's as simple as highlighting the slash, and we get a suggestion to split this thing on slashes. And now, one last thing, the dates and times, although Trifacta already recognizes this as a date-time field and is able to draw you a distribution in that format, we might want to look at the dates and times separately. So we'll highlight this T delimiter, which is a standard delimiter for date times, and we get a bunch of suggestions about what to do with this T. The one we'll choose is to split this thing on the T into two columns, one for date and one for time. And we're getting a little delay here, it looks like, with WebEx, but there we go. Once that's done, we can rename the two columns, date and time, quickly. Here we go, just by clicking on them. So that one's date, and that one's time. Okay, great. I did a little bit to our header here, which we can clean up later as well. And then finally, you know, we might want to take this header and we might want to promote it to the metadata. And so to do that, we'll click on it and just get the suggestion from this thing to promote it to the header. We press the plus button, and this is added to our script. And so now that header row is actually part of the metadata of the file instead of the file. And we'll have to go and clean up those dates and times now that we've changed the headers. So we'll just do that there, and we'll do the same thing to the time column. Okay. Now what I'm interested in the data, though, as we look over to the right here, is this disconnect reason has a lot of missing values. Why might that be? Why are there so many call detail records where the disconnection of the call is missing? And when we interact, when we click on that disconnect reason, we get transformation suggestions up here. We also get highlights in the other fields as to what's correlated with a missing disconnect reason. And if you look at the call type field, you'll see two of these bars are fully inked in because they're highly correlated, they're completely correlated with no disconnect reason. And when you look at the types of those call types in the examples, those are all SMS. They're text messages. They have no disconnect reason because there's no duration to these calls. See, they all have duration 0. And so we might take the suggestion to remove these from our analysis because calls that are SMS messages won't really reflect the quality of phone calls in the service. And so very quickly we've cleaned up that data. One of the things you'll see when you work with data like this is that folks downstream may not have as much context as folks upstream. So for instance, I may know what a disconnect reason of 11 is, but perhaps Russ or his users that he's going to be working with don't. So here what I'm going to do is a quick lookup into a dictionary to recode that 11 based on some drop codes that I have knowledge of. It turns codes into descriptions. And we quickly get the drop codes being converted into English text. All right, now we can get rid of the codes. So now we have call ended, call dropped, are two possibilities. So we've been through and we've seen how we can very quickly and very visually interact with this data and use our context as sort of experts in this data to get it into a shape where it can be analyzed. The last step of this in many analyses is that you need to bring data sets from multiple sources together. And in this case, we want to blend data on customers into this data on calls. And there's a join interface in Trifacta to do this. All right, we're going to pull out that customer data that we looked at previously, and we're going to go join it in. So here's a preview of that customer data to remind us. And when we join it in, Trifacta, by looking at column names and data types and also column values, is able to recommend join keys. Now, conveniently, in this case, these were both named IMSI, but even if they were named something different, it would have looked at these data formats and distributions and given us the match. So our join key is all set up for us, and we can click what we want in the output of the join just by sort of ticking through these fields. Let's get rid of the first names and last names and addresses here. And you know, we did an inner join, but Trifacta supports the full space of left outer joins, right outer joins, and so on. If you're an expert, you can add those. We add this join to the script, and now what we've got is we've got a data set. Remember, we started with these raw call detail records. Now we've got a data set where each call is annotated with information about the subscriber, how long they've been with the service, what country they're in, what state they're in, what's the zip code, and so on. This can now be passed downstream to a tool like Zoomdata to be analyzed. So to do this, what we'll do is we say run the job, and everything we've done in the browser now gets translated into code that can run in a big data context. So we can translate in Trifacta to Spark for interactive activity in Hadoop, or to Pig for very large batch jobs in Hadoop. And when we go fire that off, those jobs begin, and when they're finished, we can go look at their outputs. One of the interesting things you get to with big data is when you want to interact with it, you need to work with samples. But what you really want to know is how did the job you ran on the full data come out? So at the end of that job in Trifacta, you get a full data profile of everything that happened on the full data set and the distributions of the values on the full data set. So you can go through here, and this is now statistics about all the data. And you get examples of anomalies that were found while you were running the job, and you can sort of leaf through those and bring them back to clean them up. For now, we're going to say this data is close enough to write, and I'm going to export the results. I can publish this data into the Hive catalog, into H catalog, where Zoomdata can now see this metadata that we've generated. The data itself is also published in Avro format to the Hadoop file system, and it can be picked up then for efficient processing by Zoom. So go ahead and publish it, and with that, I'm going to hand it over to Russ, who can kind of take us from this point of the pipeline further down.
Great. Thanks, Joe.
So we should share the desktop over to you. Let's see.
All right, I can give Joe, I'm sorry, I can give Russ the keys if you want to do that.
I think I just managed to do it.
Oh, there you go. Yep.
I am now presenter, and I'll share my desktop. Great. Thank you, Joe. And I'm going to just jump to just a quick overview of Zoomdata at the highest level. So as Joe explained, what he's able to do is output a file, and that file could land into Spark or into Cloudera or any of these different types of data sources that Zoomdata connects to. And through our pre-built connectors, we're able to then stream data through the Zoomdata server, and the stream processing engine basically is able to support multiple operating systems, web browsers, or iPads, or Android OS. And from there, it visualizes the data in numerous visualization interfaces. At the end of the day, Zoomdata is great at connecting, streaming, and visualizing big data. Our customers are typically dealing with big data sets within the size of terabytes or petabytes of information, and they like to work with Zoomdata because of the speed in which we can generate visualizations, which are typically in a matter of seconds, and that comes from our ability to leverage the processing power of these big data sources like the Cloudera toolset or the Spark toolset. So let's say that Joe just went ahead and uploaded his information into a database that Zoomdata could access. What we're looking at here now is a dashboard within the Zoomdata interface. And I went ahead and just loaded up a couple of visualizations, but before we jump into them, let's just see how we create a visualization in Zoomdata. So we begin by adding a visualization source and select a visualization that we want to show, and I'm going to show bars vertical. And instantly, the Zoomdata server has gone ahead and queried that data source and came up with a default view of the data. We've broken down things, data sets like SMS text and then into voice calls. Now, as Joe highlighted, he also had done some work to clean up the data, and he had also changed some of the digits that describe different types of calls to things that are no description, call ended, or call dropped. I can also change my group by to state, and I instantly get a quick view of the volume of calls, or I can also change it to maybe the duration and the average duration of calls. And you can see how responsive the Zoomdata interface is in making these changes within the data sets. So looking at some of the things that we had already created in the dashboard, I had created a line chart, and let me just pop this up. So here we're looking at the average duration of calls over the course of a couple of days. But with Zoomdata, I can actually change this to an hourly look and look at the call volume over hours, or I could even go down to the minute level as well. So as we're doing our analysis of the information, we always like to look for anomalies or areas of the business that we might want to improve. So we created this one scatter plot visualization that is doing a group by state. And again, I could change this to city, I could change it to call type, but I'm going to go ahead and stick with the state view. And on the x-axis, I'm looking at just the pure volume of calls, and I'm changing the size of the dots to the volume of calls as well. Now on my y-axis, I'm looking at the duration of calls, and again, I've set it to the average call length. So when I'm looking at this scatter plot, I can see that in Michigan, the duration is pretty long for calls, but the volume of calls isn't as great. But we go to Texas, and we can see kind of the opposite. We see a large volume of calls, but the average volume isn't that high. But as a business person, I'm looking for opportunities to grow my business and to find opportunities where I can maybe get people to participate in my products even more. And that's where these three states come in. So if I look at these three states, I'm looking at New York and New Jersey and North Carolina. All three of these states are really below the norm. They're outliers here in this area. So again, as a business user, I'm going to start looking at my promotions and seeing what I can do to engage customers into the products that I'm selling to them. So let's continue looking at this analysis even further. And one of the things that I notice is that I've got a lot of groups here. I'm looking at data from text messaging systems, and then I'm also looking at voice calls. So what I'd probably want to do is to group that information. So here's a call out to Joe. Joe, would it be easy for you guys to go ahead and group this information by text messages and then by voice calls?
That sort of recoding would be, standard work in Trifacta. We saw a little recoding there, right, when we did the call drop types to text, right? This would be a similar mapping of those strings to a smaller number of strings. Maybe you'd want one for text and one for phone.
Yep. So let's say we went ahead and passed it back to his system and they made some updates. We'd come back into the Zoomdata system and look at that updated data set. So here, we're now looking at the breakout of call volume, and here we can see text and call. So we definitely have a lot more texting going on than we do call volume. But what's interesting is, so we've heard some rumors and some discussions within the business that in the Southeast, people tend to talk more on the phone than they do to actually text. So I'm just hovering over Alabama and Georgia, and I'm looking at the volumes there, and they're pretty high. When I compare them to the text, which is what I'm looking at over here, the volumes are almost cut by 50%. And here are my breadcrumbs. So here I see text here and I see call here. So, let's look at the data a little bit more. And I have this donut that looks at the actual call volume and the text volume. And I can see about 2/3 of it is text volume and 1/3 is call volume. But why don't we go ahead and filter in? And I'm going to click on this filter button here. And I'm going to look at states. And I'm going to go ahead and I'm going to pull out Alabama, Georgia, South Carolina, and Louisiana. Those are kind of states in that particular region. Now what's interesting is that we flip-flop. So kind of our theory that people in the Southeast are calling more than they're calling in the rest of the country seems to be true. And it's almost an exact opposite, where 2/3 of the people actually call from this region as opposed to texting within this region. So, let's think about this a little bit more and figure out, well, who's doing all this calling? So, with the Zoomdata tool, I have the ability to do some filtering and drill downs into the data. So I'll go ahead and I'll filter. And I'm going to filter the tree map by calls. So I'm selecting that tree map to the right, and I'm going to apply that selection. And let's expand this. So here we have all of the calls. We're looking at some of the most popular calls within our data set. And we see this person down here is making about 63 calls in this time period, and the person up here is making half as many, 36. So what would be interesting is to look at this and kind of trend this person's information. So I put on the trend line, and let's actually go down to the minute level. And actually, let's stay with the hour. Oops. There we go. So when we look at this information, this person definitely seems to be a night owl. Their calls tend to peak at around in the morning and in the early afternoon, and then the rest of the time don't seem to have too many calls going on. So when we're thinking about how we want to support people like this and provide services at their hours of occurrence, we basically might want to do some group buys and group by all the different callers and see what times a day they tend to make calls into the system. So just drilling down into one more capability within Zoomdata, and that's just basically the ability to connect to data sources. Zoomdata makes it pretty easy to, say, connect to an Impala data source where we already have data configured. And once that data is configured, oops, sorry about that. Once the data is connected to Collider Impala, whenever the Trifacta system updates that data set, Zoomdata is instantly reporting on that data. So in summary, Trifacta will be connecting to your data sources, whether they're structured or unstructured. It will be doing its data wrangling, and after that, it moves the data into a big data hub. With the Zoomdata server, we focus on connecting to that data, streaming that data, and visualizing that data. And this is essentially all data to the people. So at the end of the day, we're empowering the end user to take advantage of all these complex data sets in one intuitive user experience. So with that, I'll go ahead and pass it back to Eric.
Okay, good. And I will hand the keys over to Dr. Bloor here. Just give me a second. Robin, I think you'll have to move forward to get to your slides. Yes, I've given you the keys. And by the way, that was a great demo. I appreciate that. We got one good question already in the queue. And with that, Robin, take it away.
Yeah, sure. Actually, I'll try and go through my slides very swiftly because I think, I think most of what I've got to say is in some way or other mostly been surfaced. So, I shall go through this. But really, the statement that it's about 80% of the time is actually spent in rounding up the data and wrangling it is, well, I don't know whether it's 80%, but it's certainly a lot of the time is spent in doing that. I just thought I would talk through that. The movement of data from the acquisition through the preparation to analysis, it isn't necessarily simple, really, is what I'm saying. And if we kind of take a look at what that is, at the top where, I don't know, multiple data sources, possibly data streams, some kind of ETL process to capture the lot, drop it into, nowadays, a staging area. I mean, I think that it's quite correct to say that the traditional approach is now dead, and one is wanting to probably use Hadoop. You might use Hadoop in conjunction with a data warehouse, depending on what you're going at. But most of the data that you actually need to do anything about, because anything that comes from the data warehouse is likely to be relatively clean, if not perfectly pristine. It needs to be done on the stuff that you've dragged into the staging area. The activities down the left-hand side here are pretty much what was demonstrated with Trifacta in a sense. There's metadata discovery, a certain amount of metadata management, data cleansing, data lineage. The stuff down the right-hand side are the other things you might have to do in Hadoop, including ETL, which if you drag the stuff out possibly into a data warehouse or moving it elsewhere, it's just part of the life cycle, but that's not really what we're talking about today. And then you get analytics, and that's the way, in a sense, that's the way it now looks at a kind of software physical level. The points being made really, in fact, pretty much already made, and we've got immediate analytics, which is all of this work, data cleansing, data lineage, all of the metadata stuff, and then you've got the downstream stuff, which may be MDM, which actually can feed back into analytics, service management, lifecycle management, and ETL. If we actually look at the analytics business process, it kind of looks very much like what I've depicted down the right-hand side here. And the main point to note is that it's iterative, but if you didn't understand that this is iterative from watching that demonstration, I really don't know how I could ever explain the word iterative to you. if you actually look at this, you need to grab the data. You may grab data more than once depending upon the sources. You need to prepare that data, which is pretty much what Trifacta was doing in an interactive mode. You're modeling in one way or another. That's interactive too. You finally analyze, and you may need to have to go back. You may need to iterate between these steps before you come to some conclusion, deploy, and then execute. And the reason why this process has kind of morphed and it looks nothing like it used to do, let's say 5 years ago, is first of all, we've got huge data availability. Secondly, we now have parallel technology. It makes a lot of stuff go fast. So the kind of interactiveness that we've just seen with Trifacta and Zoomdata pretty much wasn't feasible 9 years ago. We didn't have, the technology that enabled it. We have the scalable software. We have a certain level of open source tools which enrich the environment. We also have machine learning, which actually helps in the area of analytics. The analytic latencies, the point that's made here is that, we're actually wanting a fast end-to-end process, because until the process is ended, the business doesn't actually get any value. You can do an awful lot of very clever things, but until you're actually delivering, implementing what it is that you've learned, nothing's really going on that makes a difference to the business. So the latencies that one wants to bring down are listed here. Very simple: data access, preparation, model development, execution, the implementation of the results, and possibly model audit and update. Of the things that we've discussed today, in terms of the demonstration, 1, 2, 3, 4, and 6 are actually here. And what we've actually witnessed is that it's gone from a batch process, which traditionally most of this was a batch process. It's moved from a batch process to truly a truly interactive process. And the interactive process is, if you like, it's done on a sample, so it is effectively it's model development, and then you test the model at the end by running it against all the data. That's what the demo we witnessed was. And the point that I'm making here, but the demo makes it better than I can make it. Technology is speeding up analytics by 2 orders of magnitude on the IT side, and it's changing analytics. And what we kind of witnessed in the demo is that it really has changed. So I'm going to go straight on to questions. The first thing that I actually wanted to kind of get clear is the relationship between Trifacta and Zoomdata. It's quite clear that you could use Trifacta without Zoomdata, and it's quite clear that you could use Zoomdata without Trifacta. So if you would, I guess, both like to speak to the relationship. In other words, the question is, let's say I'm watching this and I'm very interested in what I've seen. Would it be likely that I would be going to both companies? Is that the case?
Well, so this is Joe. Let me speak to that to an extent. I think one of the things that we believe in Trifacta is that to really rethink data transformation, which is our side of the house, we had to really start from the beginning and think about the interaction model, because traditionally data transformation is done by scripting or by dropping boxes on a canvas and then typing lots of code into those boxes. But it was not at all the experience that we demonstrated here with Trifacta. And what I'd say is that when you're trying to empower people to do that kind of stuff with a new technology, that takes the focus of an innovative startup focusing on it full time. So we always felt that analytics is best handled by other partners, and that we didn't need to go enter that space. The other thing I'll point out, though, on the technical side, when you look at the work we did in Trifacta, that was on data that we were manipulating and changing as we went. So as we were manipulating things, putting NA instead of blanks, or deleting rows, or adding new columns, the analytics we're able to do in Trifacta is all just-in-time stuff, right? Because the data has actually changed. You couldn't have pre-computed a chart because the data didn't exist in that form previously. And so that leads to a certain degree of analytic exploration that's possible, but it does limit sort of the amount of drill down and exploration that you can do with a tool like Zoomdata, where you have a nice clean data set that you can go cube and index and really empower. So I think the technologies at play under under the covers are different as well based on how raw the data is or how ready it is for analysis. So there's a technology differentiation in the engine side as well as, I think, in the user experience side.
Yeah, and I would just add in that the two technologies are extremely complementary in the fact that as Wrangling goes on and it's updating that point data set, Zoomdata is constantly reporting on that particular data set. What we're not doing is taking the data from Trifacta and then moving it to some sort of proprietary SQL-based database for analysis. We can both use that same database, so as changes are made by them, those changes are then represented in the reports by Zoomdata instantly.
Right. I mean, I would envisage using this. I mean, I've been a statistician, let's say, in my time. I trained to be an actuary, which is that's people who take statistics way too seriously. The impression that I get is that you would be the same, the same user would be using Zoomdata and Trifacta. You wouldn't pass one to the other, and that anybody that was doing any serious analytics might, at the point that they look at things in Zoomdata, want to go back and start messing or re-wrangling the data, so to speak, right? So the question really here is, in implementations where you're both involved, is it the case that the user is likely to be using, it'll be the same user using both pieces of software to perform whatever analytics they choose to perform?
From the Zoomdata perspective, so we've designed Zoomdata really for the business user. So our goal is to provide a visualization, exploration, analytics experience for the masses, but do it in an easy-to-use interface so that anyone can pick it up without having to receive any training. So the data scientist that really wants to do some deep dives into the data wouldn't really get the joy out of our tool as they would from using other tools that were really designed for that hardcore analytics experience for specialized analysis or reports. So on the Zoomdata side, we're more of a business user interface for a larger audience, but I'll let Joe answer the other side.
Yeah, I think from a positioning perspective, we're much more of a bridging technology. So we absolutely, our touchstone is that data to the people story. So we're building interfaces that are intended to be easy enough to use by the business analyst, but we do actually provide a lot of that joy that Russ alluded to for a data scientist as well, because to get your eyeballs on the data early and to be able to shape it and meld it and figure out, kind of what's the signal and what's the noise that you want to work with, that's something that appeals both to the business analyst and also to the more technical data scientist who wants to get in there, and we're powerful enough that you can call it to statistical functions and things to manipulate the numbers as well as the contents of the data. So we drive our interfaces from a deep understanding and lots of user studies around business users, but I would say that we also have significant adoption in sort of the data scientist realm. And I'd point out that both these companies, are very Hadoop friendly, and so what comes with that context also is sort of a next generation set of applications within the business, and so you often get more advanced users coming along for the ride with that technology.
Okay, well, and let's just ask it. What normally happens in analytic situations is that you take a look at something, you just come to one conclusion or another in terms of the model that you're trying to build to try and do something with, and pretty often, very likely, you will actually have to go and get more data. Perhaps you might, in your example, for instance, in your demo, you might want to get more data from the data warehouse that was, already pre-canned for you that you might use because there are various dimensions that perhaps you want to take into account. Or you may have other files lying around that may have come from outside, and therefore some of the metadata work that you need to do might need to be done to them. So what if I'm in the situation, I've gone through wrangling the data and I've gone into Zoomdata and had a look at stuff, and I'm thinking, yeah, something quite interesting is going on here. I need to see this other stuff. What do I do then?
Yeah, I mean, it's the same story we went through just sort of recursively, right? So suppose you wanted to look at payments data because you hypothesize that people who are doing more texting than calling are also, late on payments or something, right? So you go get that file and you wrangle it and you join it in. On the Trifacta side, it's very similar to the experience we went through with a third data source in our project. And then you pass it back to Zoomdata, which will see the change in the output, the added columns, the added attributes, and pick it up from there.
Okay, and if because the way as a data analyst or data scientist, as they're now called for no good reason, I would want I'm kind of exploring stuff, so I would want the model that I had before to be kept. And yes, I've added something in, so I might want to also save that and maybe save other models. Can I do that? Do you have a mechanism for me to freeze something and create versioning? Do you have a kind of versioning capability?
Yeah, in essence we do, right? So there's, as you saw, you're generating a script in the upper right of the screen. All that interaction you do that feels very natural. And in fact, for the beginning user, we might hide that script from them. But all of that gets captured as code in a domain-specific language we call wrangle. That wrangle script is the object that represents the work you did. And the project that wrangle script lives in can be frozen, copied, and then the copy, essentially, which is a new version, can be taken forward or modified. And there's a console and metadata kept in Trifacta to keep track of these projects for you and share them with other users and so on.
Okay, well, actually, I've run out of time, unfortunately. I'm going to have to pass you back to Eric, who's going to throw the audience at you. The other question that I was wanting to ask is, how is all of this priced in terms of who uses it? But I think there's a question from the audience that's like that. Eric, is that so?
That is exactly right. A very blunt question. How much does it cost? If you guys want to take that one first.
Yeah, I'm happy to. I mean, we price it by nodes and users, which aligns very much with our partners in the Hadoop data space. That's how pricing is often done in Hadoop. It's a subscription license. And the deals we look at tend to be in the 5 and 6 digits, depending on the use case, and the numbers roll out from the number of users and the size of your data.
Okay, good, fair enough. We got a number of really good questions here. One question, and I think you were kind of speaking to this just a second ago, and I think it was Joe, talking about this scripting language, wrangling, and its ability to write back. So, for example, if you learn something that you would like to have published back to a data warehouse, for example, whether it's for a definition or you notice a concatenation or something like that, is there that write back capability?
Great question. So, and this touches a bit on the edges of Robin's flowcharts in terms of where does the ETL, maybe without the T, maybe just the E and the L, happen as you connect warehouses to, say, the big data ecosystem and back. Because the philosophy, I think, in a lot of the big data work is that versioning is good, and oftentimes you don't want to mutate your data. You want to have a new version of that dictionary or what have you. But traditionally, back at the data warehouse, you have the golden master data of record, and you do if you're going to change it and you're approved to change it. You want to make that change on the master. So I would say, generally speaking, in the big data environment, what we're doing is we're creating new versions of data sets. So it's data in, data out, but no overwrite. However, the open source ecosystem is stepping up to the the E and the L side of getting traditional data warehouses connected to the big data ecosystem. So tools like Scoop and Flume have been around for a while. LinkedIn has now got an open source tool called Goblin that gobbles things into Hadoop. So this is happening in open source, which I think is the right thing. The pipes that connect the warehouse to the big data, those pipes, people used to charge big money to connect ETL tools to various data sources and sinks, and it's just plumbing. And that stuff is happening in the Hadoop ecosystem in open source. So, getting that new version of an output from Hadoop back into your golden master on the warehouse, that's stuff you do with open source tools today, and Trifacta can help fire off those jobs and schedule them. But that's that actual data movement happens through open source technologies.
Okay, good. That's a great answer, by the way. Here's a really good question. One of the attendees is asking, metadata, as discussed here, seems to be just about field attributes as opposed to systems information through which the field attributes are flowing. Where do I find that a field originates in silo A, rattles around and appears in silo Z? Can you kind of talk to that for a second?
Yeah, I'm happy to. I think this is and I talk about this with my colleagues on the academic side over at Berkeley, one of the biggest missing pieces in the big data open source ecosystem right now is a common metadata environment that everybody agrees on. So Trifacta has very interesting data lineage on these scripts and who generated them and what steps did they take, and we do all kinds of interesting machine learning on that data so we know what formats apply to what scripts. We don't have a standard place to put that Zoomdata and Cloudera and Hortonworks and everybody else agrees on in this open source ecosystem. And the problem is, you know, we don't want to own that. Metadata, like plumbing, sort of should be free, otherwise it doesn't get standardized. But right now the Apache ecosystem doesn't really have that metadata piece, so there isn't even an obvious place to go put that end-to-end multi-system information in the open source stack. And this is something as an academic at Berkeley with my open source hat on that I think would be great for us to build. And I'll tell you that research here at Berkeley in collaboration with people doing cancer research and genomics research, they want the same thing because they want it for scientific reproducibility. So I think we'll see, I'm kicking off some projects here in open source. I think we'll see this grow up. In the interim, you know, the answer, whether you like it or not, is probably that you have to put that stuff back in your traditional enterprise, you know, ETL kind of MDM frameworks because there's really no standard place to put it in open source today.
Okay, that's a great question. And folks, for what it's worth, since the dawn of me being in this business, that's a question that I've been asking around metadata. A lot of people have their metadata repositories, but unless you have reconciled those repositories, which is a very difficult thing to do, you're going to have these problems again and again. So that's interesting stuff. So here's a question I'll throw over to Russ. One of the attendees is asking, does Zoomdata have to move all of the Wrangle data into its own platform in order to do its job, or can you actually sit on top of another tool?
So Zoomdata really takes the question to the data. So what we like to do is help our customers take advantage of their investment in these next generation data stores like Impala or Search or Solar. So as a result, when we're querying those data, we leverage the microquery capabilities and stream the data directly from those sources. And then we visualize those directly to the users. So what we're not doing is basically moving the data. We're not making a copy of the data. We're not ETLing it into a proprietary SQL database or a legacy data store. What we're trying to do is help our customers take advantage of these big data sources that support terabytes and petabytes of information cheaply and are super fast when it comes to visualizing that data as well.
Wow, this is really cool stuff. So here's a question I'll throw over to Joe, and attendees asking, what about scalability of Trifacta? How does it wrangle billions of records?
Terrific. I'm glad you asked. It's actually the same question in some sense as the previous one, or maybe the answer is the same and the questions are different. Trifacta was built to be a user experience, not an engine. And what we do is as you interact with that tool, we use machine learning and other technologies to infer these scripts, which you saw. Those scripts can then be compiled to a multitude of platforms. The platforms that we currently target are in the Hadoop ecosystem, so you can compile them down to Pig for very large batch jobs in Hadoop. And we have customers like LinkedIn who do this at, you know, petabyte scale. Or you can compile them to Spark, which will run interactively on in-memory data sets. Or actually you can run them in JavaScript on your desktop in Node using the Trifacta tool if your data set's modestly small. So we can compile down to multiple platforms. We'll look at other platforms in future. But the point is that these transformations, which you do interactively on a sample, scale all the way up to the biggest data sets you can manage today, and that's, you know, Hadoop technology.
Yeah, that's fantastic. Here's another good question for you regarding the healthcare industry. An attendee is asking, so in healthcare, at the level of patient care providers, my end-user training for self-service analytics would primarily be in Zoomdata? Or, I mean, I can see someone in that role, if they're educated enough, starting in Trifacta as well, but maybe Joe start that and Russ take it?
Yeah, sure. I mean, the examples we have been looking at, we have a couple of customers in the healthcare space, a lot of patient records and claims data. And that is not a well-unified universe. So data comes in from lots of different places, and a great deal of work needs to be done to unify it before you can analyze it. Sometimes you'd like to say that that'll be done by, you know, a devoted team of data wranglers. and that might be the right solution. But particularly if you're trying to foster exploratory work on that data, you might like to have this all in the hands of someone who understands what you want to do with that data. If you're trying to do pricing and claims analytics, then you kind of want one person to be able to go end to end. And we've seen actually both of those scenarios play out.
Okay.
Yeah, and I'll just add on to that. So Joe's right on the complexity of the data. The data is not always clean. It's coming from many, many different sources. And when we work in projects in that space, the pharma or the healthcare space, data wrangling is a big part of getting data clean, but then the consumers of the information, usually in our space, are not always the data scientists. It's the people that are trying to make decisions on selling particular drugs or trying to do some studies on candidates for clinical studies. And what they don't want to do is spend a lot of time doing advanced queries. They want to just spend a lot of time just doing some quick lookups, filterings, analysis of the data without having to be instructed on how to use these more complex tools.
Okay, good. We have a bunch of good questions. I'll try to get to as many as possible. Spark is on this diagram here. Spark has a lot of energy, no pun intended, behind it these days. In fact, it kind of took the industry, well, here we go, by storm, which is another open source project. But can you kind of talk, I guess maybe, Joe, about how you guys leverage Spark and what it's doing for you and maybe what some of the challenges are in using it?
With pleasure. I'm actually sitting physically here at UC Berkeley, where Spark was born. We have a lot of pride in it, but I'll try to wear my Trifacta hat. So we were at a stage about a year ago where we had the scalability question answered. We could compile down to MapReduce jobs and run on the biggest data sets in the world. That was great. And we could run on the desktop in JavaScript, and that was good too. But there was a middle tier of performance where you wanted to get a good deal of data across a lot of nodes, but you wanted kind of interactive behavior. And that technology was a hole in the open source market. And as an old hand from the database industry, I can tell you, you could buy an MPP database, Greenplum, Teradata, one of those, and it would have given you that interactivity that MapReduce couldn't. But those things cost a lot of money, and they didn't talk natively in the open source domain the way that all the other sort of tools around Hadoop were talking. So Spark stepped into that environment around the same time as things like Impala and Drill, and there are a lot of similarities in those products and projects and how you'd use them. One of the nice things about Spark at the time was it was not affiliated with one of the big vendors. I think that led to a lot of excitement around it. And it's also written in a way that makes it very flexible in how you can use it because it has a SQL interface. It also has a lower level interface for the developer that's in Scala, which is a very flexible language. And it's focused on this in-memory use case where Hadoop really does very poorly. So it beautifully filled a niche in the open source ecosystem that wasn't well served by any other open source. And it did it in a way and a time where it was, I think, easier to adopt for customers. And with all that, that's what led us to choose it as the next target after MapReduce. We said, well, people are really adopting this, and we won't have to go with one of our partner Hadoop vendors. If we go this route, we can go with all of them. So that was very attractive to us.
And I would just add on to it, so our community, our application is really built around the Spark framework. One of the things that our community has really latched on to is how we basically call what we call Spark-it data. So customers have data sitting in some legacy databases like Oracle or MySQL or even S3, and they're not always the most performant. They don't support micro-querying capabilities or data sharpening. But what we do is allow our customers to connect to those data sources and basically Spark it, move that data into Spark, so that we are then helping them have a conversation in a much performant environment than they would ever have in a slower database. So the queries run faster, the filtering runs faster, and it becomes a much better experience for our users when we employ Spark.
Okay, that's great. And I'll just throw out a quick question here, maybe to you, Joe and Russ, if you want to comment on it. I actually remember studying Java, I'm almost afraid to say how long ago. I guess it was 97 or 98 or something. I spent about a month or two studying how to write in Java. That's obviously a long time ago, and there's been a lot of progress. But from what I understand, working with Hadoop, one of the gotchas, if you will, has to do with the different environments that you're in, the different versions that you're working with, and the fact that a lot of these functions will call on certain Java libraries, for example, And if you don't have everything in the right place, you're going to kind of run into some problems. There is this movement towards potentially stabilizing a great deal of the sort of lower Hadoop stack, if that makes any sense. What are your thoughts on that? And I realize you may not want to get into some of the details of what we might call the politics of what are going on right now, but that stabilization of Hadoop as a framework in this whole open source environment strikes me as a pretty good idea. Can you kind of comment on what that is and what it means for end users out there?
Yeah, let me take two swipes at that. The first one is to point out that compatibility matrices for various technologies have never been an easy or pretty thing. This is not new to Java nor to the open source community. In fact, if you're building atop SQL, you have a much worse compatibility matrix to worry about than if you're building atop of Hadoop, because there's so many vendors of SQL, there's so many variants and versions that are in the field, and that community tends not to upgrade it quite as aggressively as the Hadoop community. You know, modern software updates get pushed to you, right? And people are much more amenable in a more modern stack to kind of staying with the latest version. And there's just less variety in the Hadoop space than there is in the SQL space. That said, a second piece of Hadoop that's very exciting is that people really embrace its extensibility. This is true for Spark as well. People who are doing data science will plug in all kinds of crazy Java libraries or Scala libraries into Spark or into MapReduce, Python as well. And you can put all that together. Now, we were pioneering that back in the Postgres project in the early 90s, and you can do it in SQL databases too, but people kind of don't. Whereas in the big data environment, people do, and that does bring challenges in version management. If you've got a complex application that's, say, doing A/B testing for an ad site, and it's got not only Hadoop and all these pieces, but it's also got your crazy libraries that you've added, you have a version management challenge. What's exciting there, I think, is containerization. This stuff is going to get managed much more efficiently through things like Docker and Kubernetes than it was possible to do before in the Unix environment, and this is going to help a great deal in keeping track of versions of macro objects, you know, a consortium of tools bundled together into a container, instead of micro objects like which version of this Python library did you run yesterday. So hopefully there's some good news on the front of customization, but I would say that this is just a classic challenge in ops.
That's great. Well, folks, we burned through an hour here. I know we do have a hard stop for some of our presenters, but wonderful program today. I thought that was one of the best demos that I've seen in 5.5 years of doing the briefing room. And the old 80-20 rule that applies to people doing what we can call data science today, namely that 80% of your time is spent on prep. Well, not if you're using this stuff. This is pretty powerful. So big thank you to our presenters today. Big thank you to, of course, our own Dr. Robin Bloor for his always creative view on the world. And big thank you to all of you for your time and attention. We do archive all these webcasts. You can hop online to insideanalysis.com, look on the right-hand side for recent episodes, and take it away. And, folks, we have several more events this week. Hope you can see us later on this month, and we'll talk to you soon. Take care. Bye-bye.